Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 students who are looking for some more practice questions to prepare them for the EQAO. This video is based on questions I handed out in class, and it's the second question, so the second video where I take up questions from that handout. This is the question, or at least it's the first part of the question. There's actually multiple questions, so I'll make one video about this particular situation. So here's what it says. It says, Paige and Ryan are going to spend Saturday riding their bikes along the Bruce Trail. And the first thing says, clearly describe each of the 5 sections of Paige's bike ride. Include information about distance, time, speed, and direction. So I need to remember to always be referring to distance, time, speed, and direction. So here's the graph that shows Paige's bike ride. Oops, let me take that little mark off. And it says that there are 5 sections. So 1, 2, 3, 4, 5. So in fact, I'm going to label those sections so that when I describe them, I can refer to them as, first section. So this is the first part of her bike ride. The second part is this. There's the third part. The fourth part is that little piece. And then there's the fifth part. So by labeling them, it allows me to describe them without saying, just next or being vague. So let's look at what happens during the first part of Paige's bike ride. So we know that she starts off somewhere. Well, I need to know where that is. And to know where that is, I'm going to look here because it tells me that what I'm measuring along this vertical axis is the distance from Paige's car. So if you're here, you're at distance 0, which means you're at Paige's car. And as you go up in a vertical sense, you are moving away from her car. I also need to know information about this axis. It says 1, 2, 3, 4. But presumably, there it is. These are times measured in hours. So let's look again at this first section. She starts off at Paige's car, and then she ends up here. So how far did she go? Well, she ended up this far away, and looking at the scale, I can tell that that's 30 kilometers away. And how long did it take her? Well, now I'm going to look down here. I can see that it took her 2 hours. So let's start to describe that. So in the first section, she rides away from the car. Now, what I didn't really say anywhere is that she started at the car. So let me put that up here. I'm going to say Paige starts at her car. It's always good to know where someone is starting a journey, so that when you describe it, you have a reference point, right? Makes sense. So Paige starts at her car. And then in the first section, she rides away from her car. That's her direction. She travels. So let's review again. She travels this far. So that is 30 kilometers. And it took her 2 hours. So she travels 30 kilometers in 2 hours. So now I've mentioned distance and time. So the final thing I want to talk about is her speed. And speed is a unit rate that compares distance to time. So her speed, I could say it's 30 kilometers in 2 hours. And then what would that be in 1 hour? So dividing by 2, her speed is 15 kilometers per hour. So her speed is 15 kilometers per hour, and that's the traditional way of writing. That slashy horizontal thing in math is usually read as per, so 15 kilometers per hour is her speed in this time. And let me just clear this a little bit. You can actually see that because you can see that on the graph. If I look at what happens after 1 hour, Paige is right here, and according to the scale, she's 15 kilometers away in 1 hour, which verifies what I've measured her speed to be. So that's the first part of the first piece of her ride. And again, I mentioned direction first, away from the car. Distance and time, 30 kilometers, 2 hours. And speed is a calculation. It's 15 kilometers per hour. So let's look at the second part of her graph, of her bike ride. So in the second part of her bike ride, we see this flat line. And that flat line, boom, means that her direction didn't change. She neither got closer to the car, nor did she get further away. which means she wasn't actually moving. So she wasn't traveling any distance, she wasn't moving. So this is when she is resting. So I'm going to say she rested. And let's see, how long did she rest? Well, she started at the 2-hour mark and she ended up at the 4-hour mark. So she rested for 2 hours. So do I need to mention distance? Well, you could say 0 kilometers, I guess. Do I need to mention direction? Well, there is no direction if you're resting because you're not moving. Speed, I mean, if you want to, certainly you could put 0 kilometers per hour. I don't think it's necessary. As long as you mention how long this resting took, everything else is understood to be 0, no distance, no speed, no direction. Just make sure you say how long was that rest period for. Okay, so now let's look at the third part of her graph, or her traveling. So I'm trying to clean it up as I go here. So the third part, she's back on her bike. And then which direction is she going? Well, she started off here, which is 30 kilometers from her bike, and she ended up here. So she obviously went further away because her distance increased to this marker, which we know must be 50. So she traveled away again. So she traveled away from her car. So there's my direction. And now let's look at how far she traveled. So when she started this portion, she was 30 kilometers away. And when she ended it, she was 50 kilometers away. So she must have traveled a distance of 20 kilometers in, and let's see what her time is. So when she started this, she was 4 hours into her journey. And when she ended it, she was 5 hours. So this is a 1-hour time period. And therefore her speed will be pretty easy. 20 kilometers an hour, well, that's just 20 kilometers per hour was her speed. Okay, so that's the third part of her graph. So now let's clean that up a little bit and let's look at the fourth part of her graph. Boop, boop. So in the fourth part of her graph, you can see that she is again not changing her distance. And if she's not changing her distance, then we say that she's resting because there's no movement towards or away from the car, so she's not moving. So she was resting again, and how long did she rest? Well, from the 5-hour mark until the 6-hour mark. So she rested for an hour. So in part 4, she rested for an hour. And again, because she's resting, I don't really need to talk about direction or distance or speed because they're known to be 0. So now let's look at the final portion of Paige's journey. Oops, I erased it, but you know, it's this portion here. So from here to here, what's happening? Well, again, her distance is increasing because she's moving away from the car, which means she's driving away from the car. So we know that. So let me, so again, she rode away from the car. So now how far did she get and how long did it take her? So she started at this distance, and again, if you look at the scale, that's obviously 50, and she ended up at this distance away. So what would this be? So I'm not at 70, I'm halfway between 60 and 70, so she ended up 65. So the total distance traveled, if she goes from 50 to 65, that's a distance of 15 kilometers. And how long did it take her? Well, she started off at the 6-hour point, and when she was done, she was here. So it's beyond 8 hours, but it's not far enough to be 9, so that's 8.5 hours. So again, that's 15 kilometers from here to here, and her time, it would be 2.5 hours, because it was 6 hours to 8.5 hours, so 2.5. So let's see if I can remember that as I scroll down. So she rode, oh, no, as I thought, I forgot. So it's from 50 to 65. So 15 kilometers in 2.5 hours. So I've got distance and time, and now we need to turn that into speed. So 15 kilometers in 2.5 hours, what would that be per hour? So I'm just going to divide by 2.5 and discover that it is 6 kilometers in an hour. So her speed was 6 kilometers per hour. So that's how you would describe this journey. We don't know anything about what happens after that point. Does she go back to her car ever? I don't know, and we're not supposed to know. There were 5 parts of this journey. Let me get my pen going here. So 1, 2, 3, 4, 5. In 2 portions she rested, and the rest of the time she was traveling away from the car, and I know that because her distance was always increasing. And in each portion where she was traveling instead of resting, I mentioned the fact that she was going away. That's direction. I gave you the distance in kilometers and the time in hours, and then I did a calculation to figure out what that would be as a speed in kilometers per hour. Okay, so that's the first part of this question. So let's look at the next part. The next part talks about Ryan. Ryan's bike ride is described below. Add a line representing Ryan's bike ride to the graph. So Ryan started off 20 kilometers away from where Paige parked her car, but started riding at the same time as Paige. Now, if you have the handout in front of you, you'll notice I added this part that's not given on the handout. But as I may have discussed in class, it is important to know if Ryan starts his bike ride at the same time or if he starts at a later time, right? If he started 6 hours in, I would have to adjust to draw his graph correctly on top of this one. So here I've added that information, the fact that he starts at the same time. And because he starts at the same time, we know his starting time is also going to be at time 0. But he starts 20 kilometers away. So that means Ryan starts here. So he starts his journey at the same time, so at time equals 0, but he doesn't start at Paige's car. He starts 20 kilometers away. So then what happens? He traveled 40 kilometers in 3 hours traveling away. So in 3 hours, so between this time and this time, there's 3 hours, we know that he has to go a total of 40 kilometers. Now he's already 20 kilometers away, so 40 kilometers more would put him at 60, right? 20 plus 40 is 60. So in 3 hours, Ryan ends up here. So again, he traveled for 3 hours. That's why he had to move. Well, that's why the point is to the right. And he also traveled away from the car. That's why the point moved up. So let me just grab a line tool here. I'll use this one. So the line would be here. And that line represents Ryan doing the following things. Starting 20 kilometers away, but at the same time. And then traveling a distance of 40 kilometers in a time of 3 hours. And so that is his movement. Now, obviously, I'm assuming that he is traveling at a constant rate, you know, because if he was speeding up and slowing down, then things would not be straight lines. But it's grade 9. Let's assume that that's implied. Then what happened? He took a 1 hour rest. So we know that if you rest, you're not increasing or decreasing your distance. You're simply staying at the same distance. For Ryan, that distance is 60 kilometers. So 1 hour, right now we're at the 3 hour marker. So in 1 hour, he would be at the 4 hour marker. So here he is resting. And we know he's resting because that horizontal line means that there's no change to his distance. Then what? He continued traveling away from Paige's car. So we know that it's going to increase. It's going to go up on the graph. Distance is increasing at a speed of 5 kilometers per hour for 2 hours. So we know that this is the point. So we're talking about what happens after this point, which is the 4 hour mark. We know that he's traveling away at a certain speed for 2 hours. So we know that my next interesting point is going to happen at 6 because that's 2 hours later. But how far does he get in 2 hours? Because I'm not really sure. Well, we know he's going 5 kilometers every hour. So what I can do is on my graph, I can go to the 1 hour marker and figure out where 5 kilometers away is. And then an hour later, 5 kilometers away. Or, I like this method better, if he goes 5 kilometers per hour, but he travels for 2 hours, then he would have, 2 hours, then that means a total distance of 10 kilometers. So in the 2 hours of this segment, he traveled a total distance of 10 kilometers. So if I think about my graph, he traveled for 2 hours, so I know that that's from the 4 hour marker to the 6 hour marker, and his distance is 10, so from 60 kilometers, I need to increase that to 70, because I know it's away So it's more distance. So I went from 60 away from 70. And again, it's 2 hours. So this is, oops, let me again pull up my line tool. So this is the next piece of his graph in which he travels for a total time of 2 hours and a total distance of 10 kilometers. And then the final part of the graph says he turned around and rode back to where he started from. Well, he started at 20 kilometers away. And we know it takes him 2 hours. Now, be careful here. He can't travel like this. Why? Well, because that would be going backwards in time. That doesn't make any sense. There's no way you can go backwards in time by riding your bike. Maybe in a DeLorean, but that's an old movie reference, so don't worry about that. You can't go back in time. So he still has to increase his time, but what's happening is he now has to end up at this 20 kilometers away marker somewhere because he's going back to where he started from. So his distance is returning to 20 kilometers, but his time can't return to 0 because he can't go back in time. So what happens is, from the 6-hour marker, we know that he's about to travel for 2 hours. That takes him to 8. And he's going to end up back where he started from. So in 2 hours, from the 6-hour marker to the 8, he ends up here, back where he started from. So this portion of his graph would look like this. And so be really careful about this back to where he started from. Never show someone going back in time. Back just means the distance is decreasing because he's going back to where he started from. So remember, the up and down of a distance graph is about distance towards an object, in this case the starting line for Ryan, or distance away. Okay, so that's what his graph looks like. He rode away, he rested, he rode away, and then he rode back to the beginning for him. And that's Ryan's graph. So just before I talk quickly about the next two questions, have a look at the graph. If you look at just the Ryan portion, so ignore for a second page, just look at what we did for Ryan. Can you tell when Ryan was riding the slowest just by looking at the graph? And hopefully you can, because remember, speed is the steepness of a distance time line graph. And this portion of the graph is the least steep, meaning he traveled the least distance in 1 unit of time. And because it's not very steep compared to the other two parts of his movement, we know that he's traveling pretty slow. And just on that same thought, if I look here and compare it to here, where is he traveling faster? So just looking at those purple highlighted lines, this looks to be much more steep than this. So this is when Ryan is traveling the fastest. Okay, so just a quick review of looking at a graph and understanding things like speed. Okay, so question 3 says, at what time, if any, do Paige and Ryan meet up? So here's Paige's bike ride, boom, 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 and here's Ryan's. And what you should notice is that at a certain time, they are at the same distance from her car. And so we can assume that this is where they meet up because they're at the same time and at the same place. So at what time is this? Well, it looks like it's right about here, slightly past 6.5 hours. So just past 6.5 hours into their ride, we get this meeting between them. And I didn't ask it, but let's see anyway. Where were they? They were about 55 kilometers from Paige's car at that time. So maybe they waved, I don't know. And then finally, what was Ryan's speed during the movement described in Part E? So Part E was this final line of Ryan's, the one where he goes back to where he started from. And so to find speed, we needed to look at his distance and his time. So let's do that from the graph. So we know that this part of his graph, let's use a different color. This part of his graph starts here at a distance of 70 and ends up here at a distance of 20. So during this part, he traveled a distance of 50 kilometers. And how long did it take him? Well, we know that it took him 2 hours, and we can verify that because this part is at 6 and it ends at 8. So the time was 2 hours. So his speed would be 50 kilometers in 2 hours, and that reduces to 25 kilometers per hour. Now, an interesting thing to talk about is, would you say, we know that just by looking at a graph, let me clean a few things up here, that this is considered to be a negative slope. So perhaps I should say that his speed is a negative, because the slope of the line is negative. And what would negative mean in this context? Well, negative would mean that it's 25 kilometers per hour returning or going back or losing distance. So if you said 25 kilometers per hour, I think that's just fine. If you said negative 25 kilometers per hour, I think that's just fine too. Just make sure that you understand that if it's just a straight line, that there's positive slope and negative slope. And in a real world context like this question, what would it mean to say the slope is negative? It would mean that they're losing distance, because that's what the up and down is measuring, distance. So he's losing 25 kilometers in distance every hour. Okay, I hope that was helpful. Definitely important stuff in this question. And that's the second question on the review package, and I will post video 3.